All right, this video is about section 1.7, absolute value inequalities. Before we start, we need to talk about the properties involving them. So for a real number k greater than 0, if we have the absolute value of u less than k, that is equivalent to u being between negative k and k. If we have the absolute value of u is greater than k, we get u is less than negative k, or u is greater than positive k. So that's a couple properties that we need to put to memory, but then once we talk about it too, I think it'll stick. All right, so for the first one, we have the absolute value of x minus 3 minus 2 is less than or equal to 12. So first, let's isolate the absolute value. So we're going to have x minus, well, let me give myself some space. We're going to add 2 to both sides. And we're going to have the absolute value of x minus 3 is less than or equal to 14. Now, when we look up at our properties, we see that we have a less than or equal to, and so that correlates with what we highlighted in pink up here. So that means that absolute value of x minus 3 is less than or equal to 14 is equivalent to negative 14 is less than or equal to x minus 3, which is less than or equal to 14. So all we did is we took what was here and put it here. So because we had a less than sign here, we could write our equation in the form as so. All right, so now we're going to solve this by adding 3 to both sides. And we are left with still x in the middle. And on the left, we've got negative 14 plus 3, which would be negative 11. And on the right, we've got 14 plus 3, which would be 17. So as a set, we would write x such that negative 11 is less than or equal to x, which is less than or equal to 17. And then we can also write it with square brackets in interval notation. And they're square because of the or equal to part. All right, for the second one, I'm going to subtract 7 on both sides because we need to get the absolute value by itself. So we've got absolute value of x minus 2 is greater than 7. And now if we look up at our properties, because we have a greater than, this correlates with what we highlighted in green above. So we can write this in the form of u less than negative k or u greater than k. Sounds a little weird, but if we take that off to the side, we're going to have it in two pieces. X minus 2 is less than negative 7, or x minus 2 is greater than positive 7. And we're going to solve both of those. So I'm going to have plus 2, plus 2. So we're going to have x is less than negative 5, or plus 2, plus 2, x is greater than 9. So as a set, we would have x such that x is less than negative 5, or x is greater than 9. And then as an interval, we're going to have two separate intervals. So we're going to have negative infinity to 5 not included. Union is like the mathematical or. 9 to infinity. And really quick on a number line, what that would look like. It wasn't the question, but really quick, if we were to sketch these, this one would go from negative 11 to positive 17. These are both filled in circles. And right here, x is between the two numbers, and so we're going to shade in between. So all the solution set is everything in between. And then over here, when we have our number line, our lower number is negative 5 with an open circle. Our upper number is 9 with an open circle, and they're open because of just this greater than. Less than negative 5 would be shaded to the left, and greater than 9 would be shaded to the right. Awesome. All right, for the next section, it says solve the inequality and write the solution set in interval notation. So I'm going to zoom in a little bit, but we're going to have -1 here. And that gives us 2, absolute value of 3 minus 2x, which is less than or equal to 12. Divide by 2. So these 2's cancel or go to 1. And we're left with the absolute value of 3x minus 2 is less than or equal to 6. And so if we go back up to our properties, right here we have a less than or equal to, and that correlates with what we highlighted in pink. Okay, so because of that, we're going to take, I'm going to go over here for a little bit more space. We're going to keep what our absolute value is inside, and we're going to put that between our less than or equal to symbols, and we're going to go from -6 to +6. And really what this means here is that, I'll write it in a different color. What this means right here is that the distance is less than or equal to 6. And so that would mean that the absolute value is -6 to +6. That's all that means. Okay, so if we solve this, we're going to -3, and we need to do that on both sides. Oops. And that will give us -9 is less than or equal to -2x, which is less than or equal to +3. And then we're going to divide by -2. And when we divide by a negative, that flips our inequalities to greater thans. And over here, we're going to have 4.5, or just 9/2. And over here, we're going to have -1.5, or just 3/2. Now, this is not really incorrect, but because these are greater than symbols and they're typically less than symbols, we're going to just flip everything around to make it look how it will be on your online homework. And set notation would just be x such that with the brackets around it. Sorry, that got kind of squished. All right, for this next one, we are going to start by dividing by -9. And when we divide by a negative, that will flip our inequality. We're going to have a 3 here. And on the right side, we're going to have absolute value of 3y minus 2. Now, we need to figure out which property applies, but because our absolute value is on the right side, I think it's going to make more sense if we put it on the left side. So we're going to have absolute value of 3y minus 2. And if you notice here, the open part of our inequality goes towards the inequality, so we need to keep that the same. So we're going to keep our open side towards the inequality, 3. And if we go up to our properties, we have a greater than symbol, which correlates with what we highlighted in green. So we are going to apply this rule right here. Let me take that down here. This correlates with the green. And so we are going to have, I'm going to try to write small enough so we're not too crowded. We're going to have 3y minus 2 is greater than 3, or 3y minus 2 is less than -3. I'm going to go up and just double check that I did that correct. Yes, okay. So you flip it when you do the negative. Awesome, all right, so let's solve both of these. So I'm going to add 2 to both sides, and I'm going to get 3y is greater than 5, divide by 3, and y is greater than 5/3. For the second one, I'm going to add 2, and I've got 3y is less than -1. And then if I divide by 3, I'm going to have y is less than -1/3. And there is an or here. So if I were to graph these, there would be no overlap, but that's fine because it's an or problem. And so if I wanted to write that in set notation, I'd have y such that y is greater than 5/3, or y is less than -1/3. And then interval notation, we would have -infinity to 5/3, curved parentheses because it's not included. Union is like the mathematical or. sorry, negative 1. I did that backwards. Sorry. Oh no. We've got negative infinity to negative 1/3 union, all over the place, sorry, 5/3 to positive infinity because we've got this greater than here with the 5/3. Awesome. I think I forgot to write, yeah, let's do interval notation for this one. So this is included. It's in between these two numbers, so we have square brackets from -3/2 to +9/2.